Good morning to all. So today we'll see one more lab program, computer graphics lab program. So that is ninth one, Cohen-Sutherland line clipping algorithm. By using that, we are going to clip one of the line. So there is a one window. There is one rectangular shaped window. So the portion of the line which lie inside that rectangular window will remain, and the portion outside that window will be clipped. It clipped means cut down. Okay, not displaying the outside portion of the line. Okay, so that is the program. I will show the output, how the output will be there. So this is the input given to the program. This is the clipping window, so we call it as a clipping window, rectangular shape. And this portion which lie outside the window, clipping window, is going to be clipped means not going to be displayed, only this portion is going to be displayed. So this should be our output. So this is what line clipping algorithm. So before moving to the program, I will explain how the line clipping algorithm works. Okay, so using one diagram here, suppose this is the rectangular window we are having. Okay, so clipping window we can tell. So we are considering four cases of the line here. One is this case, another one is this case, one is this case, and another one is this case. Okay, in this case completely this line is going to be rejected to be displayed. Okay, for the display purpose it is going to be rejected. If you give the output of this, if you give the input this, the output will not be any line to be displayed. Okay, and this is the second case where complete line lie inside the window, so there is no clipping happens. Line is accepted to display, but there will not be clipping happens because completely the line is inside the window. So this is the third case where part of the line lie outside the window and part of the line lie inside the window. Okay, the output should be only this portion of the line. This should be clipped. Okay, uh, okay, and this is the fourth case where two portions of the lines are to be clipped, and this portion should be displayed. Okay, so how we are going to get that the line is completely outside, the line is completely inside, part of the line is inside and part of the line is outside? How we are going to get it? The question arises here. The Cohen-Sutherland algorithm, it uses the region codes. Okay, region code is what? Every endpoint of the line is going to be assigned with one region code. Suppose this is the input line given, this endpoint and this endpoint, we are going to assign the region codes for these two. We are going to calculate the region code for these two endpoints. Okay, so using that region codes, we are deciding whether the line is where exactly the position of the line, whether it is outside the window or inside the window, or a part of inside and part outside. Okay, so what is that region code, how it should be calculated? Okay, so the whole screen is going to be divided into 9 regions. Okay, in the Cohen-Sutherland, it assumes that the whole region is going to be divided into 9 regions. This is the region where our clipping window is there, and this is the region where outside the whole screen, but outside the clipping region. Okay, so whatever the regions are there, uh, region code is going to be given for the 9 regions here. Okay, so how that it is, this is using the 4 bits. So one is first bit indicator top, second bit indicator bottom, third bit indicator right, and fourth bit indicator left. Okay, so this is completely top of the clipping window. This region is completely top of the clipping window. So first bit, that is a top bit, should be 0, should be 1, and others should be 0. Okay, and this is completely at the bottom of the clipping window, so that is the second bit is B, bottom. So all other will be 0 and that bit will be 1. Okay, and similarly this is right side of the window and this is left side of the window, and these are the combination of the bottom and left. Okay, only those bits will be 1. Okay, and this is a top left. Okay, so top and last bit left. Okay, and this is top right it is. Okay, T1 R1 B and L are 0. So like this 8 regions are there where 8 codes are given to each region, and this is the ninth region where there is no any top, bottom, right and left, so all are 0 within the clipping window. Okay, so we are finding here the lines end, these end points of the line lie in which region. Okay, lie in which region. So depending on this concept we are calculating the region code for the end points of the given line. Okay, so just we are checking the code, so where it is. Okay, based on that we are whether we have to reject it, whether we have to accept it, whether we need a clipping for that line. Based on that itself we are going to decide. Okay, okay, so in these two cases the new endpoint is going to be calculated to display for the output, because when the clipping algorithm apply on this line, the clipping algorithm will find the intersection point between the clipping, one of the window side and the line. So this may be a one window side, this may be another window side, this may be one window side, or this may be one window side. Okay, but this line is intersecting with the bottom window side. Okay, you just find the intersection point of this and replace this point using this new point. Now the end point will be this one and this one, and using those two new end points this is going to be displayed at the output. Okay, so what is the intersection point of this? Okay, so that formula will be there, that we will apply using these two endpoints, using this side what is the intersection point. So there are some formulas, we will see that in the program. Okay, so this is the concept behind the Cohen-Sutherland line clipping algorithm. Okay, so we'll move to the program. Okay, so this is the program where, so you are defining the x min, y min, x max, y max. These are the four corners. These are the four, not four corners. This is what x min, y min. That is the left bottom corner point of the clipping window, and this is the right bottom last. Okay, x max, x y max are the. I will show you. Okay, if this is the clipping window, this is x min, y min, and this is x max, y max. Okay, so we are going to give these 2 points of the rectangle. Okay, so that is assigned, and these are the codes here. What is my right, what is my left, and what is my top, and what is my bottom. Only 4 codes we are using. Okay, right means 8 means what it is. 8 means what it is it 100. Okay. Only 3 bits are going to be used. Okay, so these are the 4-bit values assigned to the right, left, top and bottom. Okay, then we are writing here 2 functions. One is line clipping algorithm. Cohen is the line clipping algorithm which will take the 2 endpoints of the line. Okay, and compute code is one function where it takes the one endpoint and find the region code for that and return that region code. Okay, see, outcode 0 is the region code of first endpoint, outcode 1 is the region code of the second endpoint. These are the local variable it is going to be used. See, outcode 0 is equal to compute outcode for first point of the line, compute code second endpoint of the line. So this function is called, and that function will return the region code for the first point and the second point. Okay, so outcode 0 or with outcode 1. Okay, accept is equal to 1, done is equal to 1. So this is the case where the line completely lies within the rectangle. That is, if this is also 0, this is also 0, or with that is 0, not of that means 1. If this condition is 1, except is equal to 1 and done is equal to 1. If the line lies completely inside the window, that both the endpoint region code will be 0. Do you agree? If the line lie within completely within the window, this region is having the region code 000. That means both endpoints are having the value 00. You or both of them, and output will be 0 and not of that will be 1. Then accept is equal to 1, done is equal to 1. Okay, so this is that case. Else if outcode is equal to 0 and outcode is equal to 1, both are not 0, this is having some value or this is maybe having some value, but the output will not be 0. If this and this means what? Its output should be 1. Okay, output 0 and output 1, that is the region code of first point, and with the region code of the second end point, if their result is 1, when their result will be 1, if any one of these bits, see here, that is which condition it is, this is the condition, this one. Okay, when outcode 1 of this, when region code of this endpoint and region code of this endpoint, if you do the AND with it, this is the non-zero value. Okay, at that time you are completely rejecting. This is a 0 value. Okay, this is what the result of this AND is, what it is a 0. That's why we are accepting. The result of AND of these two endpoint will be non-zero, and we are going to reject it. So that is the two cases we are checking at the very first time. Okay, so this is the first case, the line is completely accepted and it is going to be displayed. This is the second case where clipping is done but line is not accepted. Else means not of both case, some. This is the else case. This may be the else case. So at that time what you are going to do, this condition else, this condition checks whether this point lie outside or this point lie outside. Okay, outcode out is equal to outcode. So this is the condition to be checked. This is the condition to be checked. What is the condition? If this is the non-zero, if this is the non-zero, you assign that value to the outcode out. Otherwise you assign this code with the outcode out. Okay, when this will be non-zero, when this point lie outside. Okay, now in this case the output 0 is 0 because x0 y0 lie within the window. So this is a not non-zero, this is a 0 value. At that time outcode 1 is going to be assigned with the outcode out. Getting? Okay, so outcode out, suppose this is the case, my case is there. So this is the outcode 1 is going to be assigned with outcode out, because outcode out 0, it is not non-zero, it is a 0. At that time this is going to be assigned. Okay, so outcode of this is going to be assigned. Okay, so if you, so on which side of the rectangle this is lied, on this side or on this side or on this side or on this side. Okay, so that you should check next. Okay, you are going to take the outcode of this. Okay, ANDing with this, ANDing with this, ANDing with this, or ANDing with this. Okay, if you and with the top, getting, if you this outcode and with the top, if it is non-zero, then it is lying this side. Okay, if this outcode is and with top, if it is a 0, then it is lying maybe like this, maybe lying this out, or maybe lying this out. That's why we are checking all the 4 options here. So whether it is lie at the bottom side, whether it lie at the right side, whether it lie on the left side, or whether it lie at the top side. Okay, so top and with outcode, if it is non-zero, it is lying on this side. Okay, so this is the first case itself. At that time, this is going to be our new point. Okay, this is going to be our new point. Only this line is to be displayed. Okay, so how to calculate this x and y? So what is my x on this line and what is my y on this line? X is what it is going to be calculated using what? Using the formula between this point and this point. You are going to calculate the x value of intersection point, that is x naught plus x1 minus x naught into y max. Y max is this is the y max. Okay, where it lies. Okay, this amount of the y max. Okay, y max minus y naught. Okay, divided by y1 minus y, and this is the formula of finding the intersection point. What is my y on this side, on this line? This amount is my y on that line. So y is equal to y max. So this is the new point. X and y are the new points. Okay, so this is going to be executed when this outcode lie on this side. Okay, if this endpoint lie on this side, okay, which condition is going to be executed? Okay, this condition is going to be executed. Okay, so that is the x max value. X is equal to x max will be there, and y intersection point you are going to calculate it. Okay, so these are the 4 conditions. Okay, okay, if outcode out is outcode 0 itself, your x naught y naught, so this must be changed. Okay, so x1 y1 should be replaced with new value x y. Okay, so our outcode out is assigned with which value? Outcode 1. Okay, so outcode out is not assigned with outcode 0, so it is go to the else part. My x1 y1 will equal to xy. Okay, so that is itself replacing x1 equal to x, y1 is equal to y1, and outcode 1 is going to be computed for this new point. Again compute the outcode for a new value of x1 y1. Okay, so this is done or while not equal to done. Okay, so only one time clipping is happen. If this line extends here, this clipping should also be happen. That's why we put into the while loop it is. Okay, all the, so after coming out of the while loop, if accept is equal to 1, so whatever the calculated amount of the values are there, these are going to be put in fx1, fx2, fy1 and fy2. These are the global variables where you are going to use the outside the function. Okay, so that is the calculated first endpoint is x naught y naught. Calculated second endpoint is x1 y1. Okay, this is my compute outcode function it is. Okay, okay, in the display function, so we are displaying first when we execute the program, along with a rectangle input line, along with the input line you are going to display. So in the display function, so x naught y naught, x1 y1, this is the line along with the rectangle x min y max. These are the what? Rectangular measures. So these two are going to be displayed. After displaying that, we should display what? Clipped line along with the rectangle. So who is doing that? Cohen function is doing that. So you give these input. This is the line I am giving. Give these input to the Cohen. So Cohen will give you a clipped line. Okay. So using mouse function I am displaying my clipped line. Using mouse function I am displaying my clip. When I click the left button, it is going to display the clipped line. So where is my clipped lines coordinate values? It is in the fx1, fy1, fx2, fy2, because at the end of the forehand, so we have assigned the clipped values to these. Okay, so that is we have done here. So along with that clipped line, so we have to display the window also, the clipping window also we have to display, that also we have displayed when I click the mouse. Okay, so similarly key, using key also you can do the same thing. When I press the D letter, so same, the clipped line along with the rectangle is going to be displayed. So this is what the concept is. So when this is the input, the initial display, when I click the left button, this will be the output. Okay, so if you have any doubt, you can converse with me. Okay, clear. Bye.